This is probably the most famous bug that I ever found. There's a bit of war stories. It turns out that if you relied on the ARM CMSIS standard stuff for interrupts on microcontrollers, which is about, I don't know, 100 million cores at this point, and you turned on LTO sometime between 2007 and 2017, you probably had a bug, a race condition, because they have bus latency, which can allow an interrupt to fire up to like 2 instruction cycles after you turn them off, and they're not actually waiting 2 instruction cycles after they turn them off, so there could be something else there. And the reason why nobody actually reported this is they abstracted it as a function in another translation unit, which didn't get inlined, and returning is more than 2 instruction cycles, right? So, lovely C++ people and brave C people that turn on LTO, ARM is sorry. But that's kind of a one-in-a-career bug defined, right? It's like very complicated and you feel really smart after you find it. Most of the bugs I see are more like this, which are stupid and no one should ever have written. This is not an atomic cube. Because even in debug mode, you're increasing the pointer before you're actually writing anything in there. And if there's a context switch in between there, then your reader is going to say, oh, there's something there, but it isn't there yet, right? And it's even stupider if you make it wrap around later. Right? If it wraps around later, it's gone off the end, you interrupt it, and then you spin in a circle until you get to your writer pointer, right? Until the reader finds the writer. But the writer is off the end, so it spins in a circle forever, right? Well, at least until you context switch back, which is really stupid if your consumer thread is a higher priority, because it'll just starve the other one. And that's really stupid if it's in like this really buff electronic motor that like controls very large robot arms. And I'm not going to be able to get like much more concrete about this because I did sign an NDA. But this is the reaction I get when I see this and the manufacturer tells me, we sold like 700,000 of these motors, mostly in China. I actually started looking at this bug because a friend of mine was using one of these motors, and he actually asked me, can you help me find this in my control software? The thing just totaled my wall. And I told him, well, you know, probably not your control software, right? It's probably lower down. Let me have a look. And like I said, this was a really, really stupid bug. And it comes from the bazillion myths around Volatile, right? Volatile seems to be one of those things that's, make it volatile and everything will work, right? And the problem is everything usually starts to work then, right? There's actually some other weird stuff though. This is something I found 2 weeks ago. It's actually from the abstraction layer of STM, and they have a market share of double-digit %, one of the bigger players. And everything builds on their ST-HAL. And so this thing's a lock, right? It says it's a lock. It's called Howlock, right? Well, this is actually a macro that returns busy as an early return. So I'm going to name this a throw lock, right? Because even though they don't understand this, they're throwing an exception, essentially. It's somewhat close to the static exceptions that Herb Sutter's proposed. And this is not the right model to handle locks. I don't know what they were thinking. And you would think, okay, I took a lock. Now I'm configuring my DMA. Oh wait, I don't actually check if that thing threw. So if you initialize DMA, it will set it to write somewhere. It just won't make it write to the place where you configured it. It's going to write to the last place it was supposed to write to, which is probably a slice that came from the heap, so you're just completely totaling memory. I probably see dead people again, except for this is just an industrial sensor, so probably not. But deprecate Volatile, please. You need something better.